One of the main things that we need to do with the definite integral is apply its use to certain topics that we can now relate to calculus. And one of those is average value. So you've known about average for a long time. All right. If I asked you to find the average of your previous 4 calculus quiz scores, what would you do? Right. Exactly. You would add up the total number of values. So you would add up all of your quiz scores, and then you would divide by the number of quizzes. So you divide by 4. And that would give you your average quiz score. We've been calculating averages forever. There's nothing new there. What we want to do now is we want to relate this to calculus and functions. And how can we find the average value of a function? All right. Well, let's take a look at some sample functions. So we see right here in purple this function f of x. All right. And we have the starting value of our bounds a, our lower bound, and then we have our upper bound b. All right. And we're interested in the average value of the function during this interval. All right. Now, sometimes the function's value is rather large, and sometimes the function's value is rather small, and sometimes the function's value is right in between. And if we were to find the average overall of the function, we'd probably be looking at something like maybe that line right there, okay? Sometimes we're above that average, sometimes we're below that average, but when we put everything all together, we're probably looking at about that value. So the question is, what is that value? Well, we can use calculus to find it, because think about it. Let's go back to what our numerator is. The numerator is when finding an average, is to get the total number of all the values. We want to find that sum, okay? Well, that would mean that we have our function f here, okay? And we want to add up all the values of that function, starting at a and ending at b. Well, what calculus, this is an obvious question here, but what calculus operation deals with adding up all those values? Hey, it's a definite integral. All right, so what we're looking at here is a definite integral. Okay, now our integral needs a low bound and upper bound, and that's going to be a and b, because we want to add up all the values from a to b. And what are we adding up? We're adding up the values of the function. So there's our f of x dx. Okay, so that takes care of the sum. Now we need to divide by all of the values. Okay, so we're interested in all of the x values from a to b. We want the range of values beginning at a and ending at b. All right? Well, you learned about range back when you learned about mean, median, and mode as well. What's the formula for the range of values? Exactly, it's the maximum value minus the minimum value. Right? So our maximum value is b, and our minimum value is a. So if we do b minus a, then we have our range. So we're going to divide this by b minus a. And this right here, this formula, that gives us the average value of the function over the interval from a to b. Because remember, a definite integral, that's just a number. All right, it's the area of the region under the purple curve right there. All right, so that's just a number. All right, so we divide that number by another number, then we're going to get a third number, and that third number is going to be the average value of our function on that interval. All right. One quick note. Yes, we can write it like this, and you may see it written like this, but it gets kind of weird with the fraction and the integral. So quite often what you will see is instead of dividing by b over a, we're going to multiply by 1 over b minus a. In other words, we just keep flip change that idea. We're just multiplying by 1 over b minus a. That's the same thing as dividing by b minus a. So this formula right here is quite often the one that you will see in textbooks, online, as the average value of a function over the interval from a to b.